Hello and welcome to another video for pre-calculus. In this video, we are going to discuss about sum and difference identities. So these are the sum and difference identities. So if we have sine A plus B, then it is sine A cosine B plus cosine A sine B. And then if we have sine A minus B, then it is sine A cosine B minus cosine A sine B. Similarly, when we have cosine A plus B, so this is the opposite. So if we have cosine A plus B, it is cosine A cosine B, and if we have plus here, it is minus. Okay, and then if we have minus, it is plus. Now for the tangent, we have tangent A plus B equals tangent A plus tangent B, and then in the denominator we have 1 minus, so it's opposite in the denominator. So if we have plus here, it is minus here. If we have minus here, it is plus here. So something that we really need to pay attention when we are using these identities. So let's look at some examples on using these identities. So the first example that we are going to look at is finding the exact values of some of these sine function. Okay, so we have sine 15 degrees, so we don't have 15 degrees in the unit circle. So we are going to use this sum and difference identity to find sine 15 degrees. So what we need to do first is we need to find two angles such that when we add them or subtract them, we get 15 degrees. And then those two angles must be the angle in the unit circle so that we can find the exact value. So here we can write sine 15 degrees as sine, we can either do sine 60 minus 45 or we can do sine 45 minus 30. Both difference, they do give 15 degrees. So I'm going to write sine 45 minus 30 degrees, okay? We can also do sine 60 minus 45 and that should give us the same thing, okay? So now we have sine, so this looks like sine A minus B. So if we have sine A minus B, it is sine A cosine B minus cosine A sine B. So let's use that. So sine, so this is 45 degrees. So sine A means sine 45 degrees. Cosine B means cosine 30 degrees minus cosine A times sine B. Now we know that from the unit circle, we know the exact values for this. So sine 45 is the square root of 2 over 2 times cosine 30 is the square root of 3 over 2 minus cosine 45 is the square root of 2 over 2 times sine 30 is 1/2. So this gives us the square root of 6 over 4 minus the square root of 2 over 4 or square root of 6 minus the square root of 2 over 4. Since we are asked to find the exact value, so we are not going to put it into the calculator, we'll just leave it here. Now similarly, we can write cosine 5 pi over 12 as cosine, so we can write this as pi over 4 plus pi over 6. So when we add this two, we get pi over 12. Okay, so now pi over 4 is same as 45 degrees and pi over 6 is same as 30 degrees. So this can be written as, now this is cosine A plus B. So if we have cosine A plus B, it is cosine A cosine B minus sine A sine B. So use the that identity here. So it is cosine A cosine B minus sine A sine B. Now we know that cosine pi over 4 is the square root of 2 over 2 times cosine pi over 6 is the square root of 3 over 2 minus square root of 2 over 2 and then 1/2. So when we combine this, we get a square root of 6 over 4 minus square root of 2 over 2, square root of 2 over 4, and then we get a square root of 6 minus the square root of 2 over 4. We get the same thing that we have here, okay? Now let's look at more examples. So tangent 105 degrees, we can again rewrite this as tangent 60 degrees plus 45 degrees. Okay, and then this is So 60 plus 45 is 105, and then we know the value for 60 and 45, the exact value from the unit circle. Okay, so tangent, so we are going to use the formula for tangent A plus B. So tangent A plus B is tangent A plus tangent B over 1 minus tangent A tangent B. So tangent A plus tangent B over 1 minus tangent A times tangent B. And then that is tangent 60 degrees is the square root of 3 plus 1 over 1 minus square root of 3 times 1. So we can rewrite this as 1 plus the square root of 3 over 1 minus the square root of 3. And let's just leave it here. This is the exact value. Now cosine 15 degrees, just be careful here, we have a negative angle, so we can rewrite this as cosine, either we can write 45 minus 60, which gives us negative 15, or we can do 30 minus 45. So let's do 30 minus 45 degrees, okay? Now we are going to use cosine A minus B formula, which is cosine A cosine B. If we have minus, so for cosine we have plus here, so plus sine A sine B, and then from the unit circle, so cosine 30 degrees is the square root of 3 over 2 times cosine 45 is the square root of 2 over 2 plus sine 30 is 1 half times cosine 45 is the square root of 2 over 2. So if we combine, so we get the square root of 6 over 4 plus square root of 2 over 4. And then we get the square root of 6 plus the square root of 2 over 4. And this is the exact value. Now this one, so earlier we were going from left to right using those identities. Now if you look over here, we have the expanded form. So what we have here is sine 86 cosine 94 cosine 86 sine 94. So this is same as sine A cosine B cosine A sine B. So if we look here, sine A cosine B cosine A sine B. So it is just like this one, and we have a plus. So it is this formula. Okay, so now we can rewrite this as, so we have sine A cosine B plus cosine A sine B. Then we can write this as sine A plus B. And then we get sine 86 plus 94 is 180 degrees. And we know that sine of 180 degrees is 0. So let's go ahead and verify some identities using sum and difference formula. So the first one is we are going to verify that sine pi over 2 minus x equals cosine x. Okay, so let's go ahead and verify this. So let's start from the left hand side because that looks a little bit more complicated. So left hand side equals sine pi over 2 minus x. So this is same as sine A minus B. So sine A minus B is sine A cosine B minus cosine A sine B. So let's use that difference formula. So sine A cosine B minus cosine A sine B. And then sine pi over 2 is 1 times cosine x minus cosine pi over 2 is 0 times sine x. And that gives us 1 times cosine is cosine x minus 0 times sine is 0. So we get cosine x, which is the right hand side. That means we proved this. So now let's look at the second example that we have here. So again, let's go ahead and use the left hand side and let's get the right hand side. So left hand side equals, so this is tangent pi over 4 plus x. So this is tangent A plus B. Okay, so we can use the formula. So tangent A plus B is tangent A plus tangent B divided by 1 minus tangent A times tangent B. And then tangent pi over 4 is 1 plus tangent x divided by 1 minus, so tangent pi over 4 is 1. That means tangent x here. So we obtain what we have on the right hand side, which means we proved this identity. Let's look at one more example. So here we are going to prove that sine theta minus beta over cosine theta cosine beta equals tangent theta minus tangent beta. Okay, so let's go ahead and start with the left hand side. Equals sine theta minus beta over cosine theta times cosine beta. So sine theta minus beta is same as saying sine A minus B, so which is sine A cosine B, sorry. This means sine theta cosine beta minus cosine theta sine beta divided by cosine theta cosine beta. So let's go ahead and separate this fraction. So sine theta cosine beta divided by cosine theta cosine beta minus cosine theta sine beta divided by cosine theta cosine beta. And now we can cancel some common factor here. So we can cancel cosine beta and cosine beta and cosine theta, which means we will get sine theta over cosine theta, so it is tangent theta here, minus sine beta over cosine beta is tangent beta. And that's what we have on the right hand side. So that means we proved this identity. That's all for this section. I'll see you again in the next video.